Hello. We are going to continue today with our trig identities unit. Today we're going to look at compound angle formulas. You can see the 6 compound angle formulas listed below. We don't need to waste time reading them through, but they're pretty straightforward once we get used to them. Okay, so let's go right down to the examples. Express as a single trig ratio using an appropriate compound angle formula. Okay, so the first one we have cos of theta times cos of 2 theta minus the sine of theta times the sine of 2 theta. Okay, so what we're doing here, since we want it as a single trig ratio, is we're going to look for the formula that is similar to that. So it's cos times cos minus sine times sine. And we know that we can see that the cos times cos minus sine times sine comes from our first one, which is cos x plus y. And you can see in the formula, it's cos x times cos y. And in the one that we're working with, it's cos theta times cos 2 theta. So these are going to represent our x and our y. Okay, so when we're simplifying it, we know that this is the cos x plus y formula. So we have cos x plus y, or cos theta plus 2 theta. And then we just simplify that into cos 3 theta. Okay, and that's all. The next one, okay, we know it's going to be one of the tan compound angle formulas. We have tan pi over 3 minus tan pi over 4. All of that over 1 plus tan of pi over 3 times tan pi over the 4. So there's 2 tan equations, compound angle formulas. One has a plus sign on the numerator, a minus sign on the denominator. The other one is the opposite. We can see the one we're working for is a minus on the numerator. So that tells us we will be working with tan x minus y. So I'm just going to delete that. Okay, so we know that it's tan x minus y. If you need to write that, that's fine, and then we can fill it in. So the x here is the first bracket listed, so pi over 3. We're minusing pi over 4. And then we're going to simplify that with our common denominator. So common denominator here being 12. So pi over 3 is the same as 4 pi over 12. Pi over 4 is the same as 3 pi over 12. So the simplified answer here is tan of 1 pi over 12. Okay, now the other way. Number 2 is determine the special angles that will add up to these set amounts. And before we do that, I'm going to quickly draw our unit circle. Okay, feel free to fast forward this part if you want. Okay, so the green parts are the 0, 90, 180, 270, or we also know them now as pi over 2, pi, 3 pi over 2, 2 pi. Okay, the purple ones, I don't like how far that goes. We have our 30, or pi over 6. $150, 5 pi over 6. 210. Yep, 210. Red is 45 or pi over 4. Okay, we have our unit circle here, and this is going to help us find two special angles that add up to these things. Okay, so ones that add up to 365, we have two options here. So, and we want it to be one of the degrees that's listed. So the ones that add up to 365, or 165, sorry, is 135 and 30. Or we could use 120 and 45. Okay, those should be the only ones that add up to 165. So when we're plugging these into our formulas, we could use either of these as the x and the y. Okay, negative 19 over 12. So negative 19 over 12, we're going to use two negatives, and I'm just going to speed through this. We're not going to actually worry about the lowest common denominators and figure it that way. But 5 pi over 6 and 3 pi over 4, right? If those were common denominators of 12, it'd be 10 and 9, and that adds up to 19. So let's use negative 5 pi over 6 plus, or just minus, 3 pi over 4. Okay, and then we could also use negative pi over 4, take away 4 pi over 3. Right, again, common denominator 12. So the first one would be 3 over 12. The last one would be 16 over 12. And 3 and 16 add together to make 19. Okay, great. Number 3, determine the exact value of each using a compound angle formula. All right, so now we're going to split the angle that we're given up here into two special angles, and then we're going to use the formulas. Okay, so 13 pi over 12. So you'd work through it again. When you're working with 12, you're probably going to be using denominators of 6, denominators of 3. Actually, you can use any of them, but a lot of times it's going to be the denominators of 4 and 3. And this will just take some time of working with it, and you'll get used to figuring out which ones work. I'm going to use sine of 3 pi over 4 plus pi over 3. Okay, as a denominator of 12, that would be 9 pi over 12 plus 4 pi over 12, and 9 plus 4 is 13. Okay, so we have a sine x plus y formula here. So we're going to look at the top here. Sine x plus y is sine x times cos y plus cos x times sine y. So let's figure this out. So we have sine of our x value times the cos of our y value plus the cos of our x value times the sine of our y value. Okay, and then we would look at the actual unit circle that we had from lesson 2, and we would figure out that, well, sine 3 pi over 4 is root 2 over 2. Cos of pi over 3 was 1 over 2. Okay, the cos of 3 pi over 4 was negative root 2 over 2. And the sine of pi over 3 was root 3 over 2. Okay, then we can multiply. So this first one, we get root 2 over 4. The second set, we have negative root 2 times root 3. So that's negative root 6 over 4. And you can't add roots that have the different bases together. So we get root 2 take away root 6 over 4 as our answer. Okay, great. Took up some of the space here. Cos of negative 15. Okay, so we don't have any numbers smaller than 15 in our unit circles, so we're not going to be adding two negative numbers together, but we could do the cos of 45 degrees take away 30 degrees. That gives us the 15 we're looking for. Okay, if you wanted to use 60 and 45, you could use any of them. If you wanted to use 150 and 135, whatever, up to you. But this one is the most basic, so let's work with it. Okay, and cos x minus y looks like this. Cos x times cos y plus sine x times sine y. So we have cos of 45 times the cos of 30 plus this, plus the sine of 45 times the sine of 30. Okay, and our unit circles will tell us cos 45 is root 2 over 2. Cos 30 is root 3 over 2. Okay, sine 45 is also root 2 over 2, but sine 30 is 1 over 2. Okay, we multiply these out and we have root 6 over 4, so very similar to the other one that we did. Root 2 over 4. Denominators are the same, can't add the root 6 plus root 2, so we have root 6 plus root 2 over 4. Okay, one more. This one takes a bit of time. Find the sine of a plus b, cos of a plus b, and tan of a plus b, where a and b are obtuse angles. And we know that the sine a is 3 over 5, and sine b is 5 over 13. Okay, so we're going to work with two parts here. Okay, they're obtuse angles, which tells us they're going to be in quadrant 2. When it says sine is, so this is for A, sine is 3 over 5, so opposite over hypotenuse. And I would use Pythagorean theorem. I'm not going to waste your time. 5 squared take away 3 squared is 4 squared. And we know because it's in quadrant 2, our x value is negative. Okay, so for here, sine A, what we already know is 3 over 5. Cos A is adjacent over hypotenuse, and tan A is opposite over adjacent. Good. And we have one more, because now we need to find the angles for B. Again, this is an obtuse angle. And it says sine B is 5 over 13. So opposite is 5, hypotenuse 13. 13 squared, take away 5 squared is 12 squared. So we have sine B is the 5 over 13. Cos B is negative 12 over 13. And tan B is negative 5 over 12. Great, now we know our A's and our B's, so let's work with this. Okay, sine A plus B, so we're working with the signs. We know our A, we know our B, so sine A plus B is the same as sine 3 over 5 plus 5 over 13. And we're going to use the angle formula of sine x plus y. So that is sine A times cos B plus cos A times sine B. And then we just use the fractions that we found in the first box to fill this in. Okay, so sine A is 3 over 5. Cos B is negative 12 over 13. Cos A, negative 4 over 5. And sine B, 5 over 13. Okay, we multiply these out, we get negative 36 over 65. Over here we get negative 20 over 65. Okay, negative 36 plus negative 20 is negative 56 over 65. And that's our answer. Okay, moving on to cos A plus B. And cos A plus B has an angle formula of cos A times cos B minus sine A times sine B. All right, so we fill these in with our fractions, negative 4 over 5 times negative 12 over 13 minus 3 over 5 times 5 over 13. Okay, so we get 48 over 65, take away 15 over 65, which gives us 33 over 65. Can't reduce any further. Okay, and then the last one, tan A plus B. So the tan compound angle formula is tan A plus tan B, all that on top of 1 minus tan A times tan B. Okay, only worrying about the tans here. So tan A is negative 3 over 4, tan B is negative 5 over 12. So we have negative 3 over 4 plus negative 5 over 12, all that divided by 1 minus negative 3 over 4 times negative 5 over 12. Okay, you need a common denominator on the, when we're adding the fractions in the numerator, that is 12. So we have negative 9 over 12 plus negative 5 over 12. On the bottom, we're going to have one takeaway. When we multiply those out, we get 15 over 48. So this gives us negative 14 over 12 on top of 48 over 48 minus 15 over 48, so 33 over 48. Okay, when we're dividing fractions, so let's move it over here, it's going to be negative 14 over 12 times 48 over 33. We can simplify the 12 and the 48. That moves to 1. That goes down to 4. So really we have negative 14 over 1 times 4 over 33. And that's going to give us negative 56 over 33. Okay, hopefully it makes sense. This is all new to us. The more you practice, the more it'll make sense. You'll be given the unit circle on your test, so don't worry about redrawing it.